I'm Anil Kumar. Welcome to our series, Anil Gurmeen series on polynomials. I hope you are enjoying the outdoor learning. In this video, I'll also answer a few great questions put forward by Gurmeen, and we'll discuss the topics mentioned here. So let's begin with the very basic concepts of factor theorem and also understand why do we check only few integer values for potential zeros. We'll take a few examples as given here and derive also formulas for sum of cubes and difference of cubes. The last question here is a bonus question for you. It's seen sometimes in test papers. Now let me actually begin with remainder theorem. If I'm dividing the function of f(x) by, let us say, x minus a, then what we know from here that the remainder is equal to value of this function for x equals to a, right? That's what it is. Now that brings us to the definition of factors, and that is if f of a, that is to say if the remainder is 0 equals to 0, then x minus a is factor of f of x. Does make sense, right? So if the remainder is 0, only then that particular term is a factor, correct? So that is the basic definition of factor theorem, right? Sometimes we generalize it, and that is to say that we say if ax plus b is factor of f of x, then f of what makes this 0? Minus b over a should be equal to 0. Perfect. So that is the factor theorem, right? So it's obvious if the remainder is 0, then it is a factor. Now we'll look into possible values to find this particular factor. Let me add few things here about the factor theorem. This is when you do algebraically, right? But if I give you a graph, then it is very easy to find the factors, right? For example, if I sketch a graph like this, let me just draw something here, right? Okay. So if I'm sketching a graph like this, then all these x-intercepts which you see correspond to factors. So we have, in this particular case, we have 3 factors. Now if I know these points, let's say this point is minus 4, this is, let's say, plus 1, and this is, let's say, 3. In that case, what we can say about factors, we can write very clearly that x plus 4, x minus 1, and x minus 3 are factors. Perfect. Since at these points minus 4, 1 and 3 we have zeros or x-intercepts, the y value is 0. Perfect. So the function f of x is 0 at some values of x. They correspond to the factors. Okay. Possible values of x for potential zeros. Now let us take up an equation to give you some idea. Let's say if f of x is equal to, let me write a cubic equation, x cubed minus 3x squared minus 4x plus 12. Now to factor this, we have to try out some values. Now the question here is, what could be possibly be? Let's talk about integer factors, right? So most of the time when we are doing so what could possibly be integer factors? Most of the time when we are factoring, we are only interested in integers, which could make this particular polynomial 0. It's very difficult to try rational numbers as such, right? There will be times where we'll be using rational numbers, but most of the time, especially when the coefficient is 1 here, then we talk about integers only. Okay, so let's look into possible, what could possibly be integers. So now, to factor a polynomial, we have to try some integer values. Whenever we're talking about factoring, we are actually only working with very simple numbers. It could be very tricky, and most polynomials cannot be factored, right? Let's remember that. Now let me show you a small variation to this equation. We see in first part there are some x values, and we can take x common. So I could write this as x times x squared minus 3x minus 4, and let's keep this 12. Now we just factored out x from here. Now we are looking for factors, that is to say, let us say that x equals to a gives us a 0, that is to say f of a is 0. Let us assume this, right? In that case, a times a squared minus 3a minus 4 plus 12 should be equal to 0. Perfect. Because we are saying that x equals to a gives you a factor. That is to say, x minus a is a factor. Correct? Now, if I rearrange this, what do I get? I get a times a squared minus 3a minus 4 equals to minus 12. Now for a to be integer and factor of 12, right, that directly indicates you what? We want this to be factor, right? That means a should be related with 12, right? So a could possibly be what? We know the factors of 12 are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. So if that equation has to be true with some integer values, right? We are saying a belongs to integers. In that case, a could only be factor of 12. You get an idea. So from here, you could conclude that generally, to find potential values of x, we have to look for factors of the constant terms, right? So from here, we could conclude that factors of constant term let's say can be tried as potential factors of the polynomial. Does make sense, right? So that is what we conclude from here. Now in this case, 12 is the constant term, so that should be the limiting factor. So these are all the possible values which you could try to find factors, right? So, for example, if I try 2, let's try what is f of 2 equals to. F of 2 is equals to 2 cube, which is 8, minus 3 times 2 square, minus 4 times 2, plus 12, and that is equals to 2 cube is 8, and 4 times 2 is 8. So that becomes 0, right? So these two cancel away. And 4 times 3 is 12, and that is 12. That cancels away. So we really get 0. So that really means that x minus 2 is a factor. Does make sense? So with this example, we learn that we can find potential factors by trying the values which are factors of the constant term, correct? Now let's generalize all these learnings at one place. So let's get back to the basic concepts of factor theorem. We say that x minus a is factor of f of x if and only if. So if I write IFF, it means if and only if f of a, which is the remainder, equals to 0, right? So if and only if f of a is 0. In general, we could also write it like this. Let's say ax minus b this time is factor of f of x if and only if f of b over a equals to 0. What makes this 0, right? So I don't follow a very standard thing, since different books use different things, and in different continents we work in very different ways. But you should understand the concept. Whatever makes this 0 comes here. So that is some basic about what could be the factor and what is treated as a factor. The other thing is that if I have this function f of x as equal to, let us say, x to the power of n plus, let's say, a n minus 1, x to the power of n minus 1 plus a n minus 2, x, this is x, x to the power of n minus 2 plus so on, let's say a1 x plus a0. Let's say this is our general polynomial. In that case, possible values to try for factoring are factors of the constant a0. This is very important, right? So all factors of a0, right? So this is, we're talking about integer factors only, right? Now it could be extended. So at times we could have a polynomial. Basically we could have some other term here. For example, an, right? X to the power of n plus an minus 1, x to the power of n minus 1, general polynomial, right? Let's say we have a2x squared plus a1x plus a0. Now in this case, you could actually take an common, right? So if I take an common, then we get everything inside. And what you really note here is that the last term becomes what? I mean, the last term, a0, could be written as, let's write this, as a0 over an. Do you see that? So basically we get x to the power of n plus an minus 1 over an, x to the power of n minus 1 plus so on, a2 over an x square plus a1 over an x plus all this. Do you see, if I have a leading coefficient not equal to 1, then what we get here is a rational number. So we talk about rational factors. So in that case, the possible values are what? Now in this case, what we have is all combinations of factors of constant term a0 divided by combinations of factors of leading coefficient an. So if you're taking a general expression, then in that case, this constant term could be treated as a0 over an, right? Think about factoring it out. In that case, this ratio is all the values which you're trying. And remember, with plus and minus sign. You get an idea, right? So we'll explore this and take a few examples to show you what I'm trying to say. I hope that makes sense, right? So let's move on. Now here is an example to factor polynomial. We'll factor x cubed plus 2x squared minus x minus 2. So from our learnings on factor theorem, what are the possible values which we should try? So we say possible values are x equals 2, factors of 2, right? So it could be plus minus 1 or plus minus 2. Correct? So these are the only two possible values which we could, rather four, which we could try. So for this function, let's calculate what is f of 1 equals to. So f of 1 will be 1 plus 2 minus 1 minus 2, which is 0. So that means f of 1 is a factor, right? So that means x minus 1 is a factor. Do you see that? Similarly, we could try all other values and test it out. Now, the idea here is, if it is a cubic function, and if you get the first factor, then we could do division and divide and get the other factors. So that is how we are going to factor polynomials. So let's do long division this time. In the next example, we'll take up synthetic division. So here we have x cubed plus 2x squared minus x minus 2. We are going to divide it by the factor x minus 1. So taking first two terms, we could multiply by x squared. So that gives us x cubed minus x squared. Taking away, we get 3x squared minus x. Got to multiply by 3x. So you get 3x squared minus 3x. And when you take away, you get plus 2x. That becomes positive, minus 2. And now we can multiply by 2 to get 2x minus 2. When you take away, remainder as expected is 0. Correct? So what we have done here is written our function, let's rewrite, f of x as divisor times quotient, which is x minus 1 times x squared plus 3x plus 2. So we have written a cubic function at this stage. You can see what we have done basically is we have written a cubic function with 1 degree lower, right? So we have linear plus quadratic. So this part is quadratic. Now we know how to factor the quadratic part. We are looking for product of 2 and sum of 3. So it is 2 times 1. So we could further factor it as x plus 2 times x minus 1. Correct? Now if you observe, what do you notice? You note that the integer values are what? Which makes them 0. We have x equals to 1, x equals to minus 2, and x equals to, this is plus, sorry, minus 1, right? 2 times 1, positive, right? When you add, you get 3. So basically, all the 3 numbers which you get here, rather integers, are factors of the constant 2. Do you agree with me, right? So this is the basic concept, and it helps you to factor any polynomial. Correct? Now let's move on and take example where we have a leading coefficient. So in this particular example, we have leading coefficient 5. So what values of x should we try? All factors of 4, which are plus minus 1, plus minus 2, plus minus 4. This is 1. Then we have to try ratio of factors of 4 and 5. Now this could be treated as, factors of 5 is also 1, so this is divided by 1. The others are 5 itself, so we'll try plus minus 1 over 5, plus minus 2 over 5, and also plus minus 4 over 5. So we have 1, 2, 3, 4, 5, 6 times 2, 12 values to try, right? So possible 12 possible values. Now in multiple choice questions, that could be one type of question, right? So how many possible values of x could be resulting into the factor of a polynomial? You get an idea, right? So let's try them one by one. That's the whole thing. So let's say what is f of minus 1 equals to. So you can actually use a calculator, do it very fast. So if I write minus 1, you get minus 5. This gives you plus 3. That is minus minus becomes plus 12. And this is plus 4. Now clearly this is not equal to 0. Right? So that doesn't work. Let's try 2, for example. So likewise, you have to try different values to get this particular thing correct. So if I try plus 1, for example, in that case, this will be 5 plus 3 minus 12 plus 4, right? Now 5 plus 3 is 8, 8 plus 4 is 12. So we do get our 0, right? So this is the first 0 which we got. That's good. So that means x equals to 1 gives us the first factor. This time we'll do synthetic division to get the other factors. So let me write this coefficients now, which are 5, 3, minus 12 and 4. Since 1 gave us 0 remainder, we'll write down 1 as the divisor in this case. So we are now doing synthetic division, correct? So bring down 5, multiply, write down here, add. So basically here we actually, as you remember, times this and then write it here. And when we move downwards, we add, correct? So add 5 and 3, you get 8 times, you get plus 8 minus 4 times minus 4 as expected, remainder of 0, correct? But this gives you a quadratic function. Right? So we can now continue to write 5x cubed plus 3x squared minus 12x plus 4 as equal to x minus 1 times this quadratic function, which is 5x squared plus 8x minus 4, right? Now 5x squared plus 8x minus 4 could be factored, correct? Now here 5 times 4 is 20 with negative sign. So we're looking for now to factor this. We're looking for numbers p and q whose product is negative 20 and whose sum should be 8. So sum of 8, negative 20 product means the two numbers could be 2 and 10, right? So you could try the numbers 2 and 10, where 10 is positive and 2 is negative. So we'll now factor the term 5x squared plus 8x minus 4. So let's rewrite. So write 5x squared plus 8x minus 4 as equal to 5x squared plus 10x minus 2x minus 4. Taking 5x common gives us x plus 2. Taking minus common, minus 2 common, will also gives us x plus 2. And now x plus 2 is a common factor, which results into 5x minus 2 as the other factor. So what you see here is that the given function could now be written as what? Let me write here and then I'll copy it there. So the given function could now be written as product of all these factors, which are x minus 1 times x plus 2 times 5x minus 2, right? So that becomes the factored form of the given polynomial. Perfect. So as you see here, the factors are at x equals to 1. The other one is at minus 2. So we get x plus 2 as our factor. The third one, which is 5x minus 2, is 2 over 5. Correct? So 2 over 5 with a positive value is one factor. Minus 2 is another factor. And plus 1 is also a factor. So what you notice here is it is only from this list that you get factors. Does it make sense to you? So now this becomes a very good method to find factors of a polynomial. Now once you factor a polynomial, you could solve many questions related with it. So it's a huge technique. So I hope you find it important and useful. Now we'll take a few examples, and especially I want to take a difference of cubes and sum of cubes, as that also helps us to factor polynomials. Now we are going to use factor theorem to derive a formula for x cubed plus y cubed. Now if x equals to minus y, then what happens? In that case, x cubed plus y cubed could be written as minus y cubed plus y cubed, and this is equal to minus y cubed plus y cubed, which is 0. Now that means what? That means x plus y is a factor of x cubed plus y cubed. Does it make sense to you? Correct? So if I substitute x equals to minus y in the expression x cubed plus y cubed, we get 0. That means x plus y is a factor. Correct? Now if x plus y is a factor, we could find the other factor, right? So let's do it. Let's find the other factor. So we're going to use synthetic division to find the other factor. In this term x cubed plus y cubed, many terms are missing. The coefficients for x0, x square and x are missing, right? So what we're trying to do here is we're going to divide x cubed plus y cubed by x plus y, right? Remainder should be 0. So what makes it 0 is minus y. So I'm going to divide by minus y when you do synthetic division. Here, let's put the placeholders for the missing terms. 1 is the coefficient here. Then we have 0 for x squared, 0 for x, and then we have y cubed. Now some of you may be getting confused why I put 2 zeros in between. Now the reason for these 2 zeros is we are writing this as x cubed plus 0x squared plus 0x. I have to position these two properly to do proper synthetic division, right? And the constant term y cubed. Now I hope it makes sense, right? So these zeros corresponds to the placeholders, right? So these we term as placeholders. Okay, so now let's continue with the synthetic division part. Bring down 1, multiply by minus y, add, so you get minus y, multiply, so you get plus y square, add, you get y square, multiply, you get minus y cube, add, you get 0. Perfect. So that's the remainder, which is 0. So we have the other factor whose coefficients are 1 minus y, y square. So I could now write x cube plus y cube as equal to the first factor, which is x plus y, times here. This is the coefficient of, this is a quadratic equation, right? So x squared minus yx plus y square. So this becomes the general formula for a plus b whole cube. Right? Similarly, you could derive the formula for x cube minus y cube. What you're going to get is x minus y times x squared plus, you could write this as xy, right? Plus y square. So that will be the second formula which you could derive. So let this be your exercise. So this is your try it out. Is it okay? Now we are going to use these formulas to factor polynomials. So let's take up the next example. Well, I would like you to try examples from your book. Here is one. Factor x to the power of 6 minus y to the power of 6. Now, x to the power of 6 minus y to the power of 6, we could begin with writing this as x squared whole cube minus y squared whole cube. Right, so that is how we could write our polynomial. Now we could apply the difference of cube formula, which we just learned. Let me write in different ways. If I say a cube minus b cube, it could be factored as a minus b times a square plus ab plus b square, right? So applying this formula directly, we could always write the polynomial as x squared minus y squared. Now, as you can see in this example, a is x squared, right? And b is y squared. So we just substitute these values and we are going to write the factors. So square of a will be x to the power of 4, correct? Plus product of these two, which is x squared y squared, plus square of y squared, which is y to the power of 4. So I hope that is clear, right? Now here we have difference of squares, so it could be further factored and written as x plus y times x minus y times x to the power of 4 plus x squared y squared plus y to the power of 4. So we'll also note that many times you may have to do multiple steps of factoring as we've done here, correct? So we apply difference of squares formula here. Which is a square minus b square equals to a plus b times a minus b, correct? So that helps in factoring. So we have done this kind of factoring with the factor theorem and also by application of formula. So I hope that helps. Now let me take a bonus question which is kind of difficult. I'd like you to pause the video, factor the given polynomial, and then look into my suggestions. We are almost at the end of our video, and I hope you've learned what is factor theorem and how it can be applied to factor polynomials. Now here is a bonus question for you. In many tests I've seen this. You need to factor ax cubed plus a minus b whole x squared plus minus 2a minus bx plus 2b. Now, the basic concept is same. To factor, we are looking for possible factors of 2b, right? So, values to be tried are factors of 2b, right? So, you could try, for example, plus minus 1 or plus minus 2 in this given expression. So, let us say what is the value of this function at x equals to 1. So if I write 1 for x, then I get a plus a minus b, and let's open this bracket. So we get minus 2a minus b, and here we get plus 2b. So that gives us a and a is 2a, 2a minus 2a is 0, minus b is 2b minus, and that is also 0. So that gives you 0. That means x minus 1 is a factor, correct? So if the remainder is 0, we know it leads to a factor. Now since it is a factor, it can help us to find the other factors of the given polynomial. So now I'll do synthetic division. We'll divide this time by 1, since 1 gave us 0, and we write down the coefficients. For x cubed, the coefficient is a, then for x squared it is a minus b. Here we have minus 2a minus b. The constant term is 2b. Okay. So let's bring down a, multiply by 1, so we get a. Let's add, so we get 2a minus b. Multiply, we get 2a minus b. Add minus 2b, that becomes 0. Multiply minus 2b, add to get 0. As expected, the remainder is indeed 0. So this time, that is our expression, right? So basically, what we landed up is that the second expression, let me write down this second expression separately. So we are saying g of x as equal to, since we divided cubic, this is a quadratic function, so it is ax cubed square, quadratic function, plus 2a minus b x minus 2b, correct? Now we could do sum and product, or let's go ahead with the factor theorem itself. So let's try some more values. So when you try values, you could try plus minus 2. Now since we have, let's try g of minus 2, right? So try some values. If I write g of minus 2, what do I get? Minus 2 for x, I get 4a here, right? This is minus 2. And if this is minus 2, if I open the bracket, I get minus 4a plus minus 2, so plus 2b and minus 2b. This is when x is equal to minus 2, and that is also equal to 0. Do you see that? Substituting minus 2 gives us another factor, and that means that x minus 2 is a factor, correct? So that means x minus 2 is also a factor. So let's do synthetic division with this expression this time. So this time we are going to write down the same coefficients, which is a, 2a minus b and minus 2b, and divide by minus 2. Okay. Bring down a, multiply by minus 2, so get minus 2a, add, they cancel, you're left with minus b, multiply, you get plus 2b, right? And as expected, you get 0 as your remainder. And that's your linear expression. Is it okay? So what we got here was quadratic. We called it g of x. Now this is linear. right? So that could be written as ax minus b, right? So that is your factor. Perfect. That's the remainder. And therefore, we get our answer, and we could write the function f of x as product of all these factors, which are x minus 1, x minus 2, and ax minus b. Do you get the idea, right? So these are all the factors which we get for the given expression. You get it, right? So that is how we could factor such a polynomial. Now this is indeed an excellent question. I'd like you to go through this video once again, understand the concepts. I'll also provide you with links on my factor theorem practice questions. Go through those questions and then get ready for a test on polynomials. Thanks for watching. Feel free to share your comments and views on our outdoor learning process, and also share your test papers and questions so that we could work and provide you with good practice problems. Thank you and all the best.